structure, the working, right, of BJT. Then we started the MOSFET and JFET. So JFET and MOSFET are the types of FET, field effect transistor. So we also studied about what is FET, right? Then what are the types of FET, that is JFET and MOSFET. And we understood the working of JFET, what is the structure of JFET, how MOSFET is different from JFET, what are the characteristics, that is input characteristics and output characteristics of JFET and MOSFET. So we discussed all these things in last 2 3 sessions. Now we move forward to the new session that is related to our digital system, right? So first in the session we will understand what is the difference between analog and digital, right? And how we use the digital system, how digital system was created. Uh, in next session we will understand about the number system, right? The conversion of the number system. Okay, so we will understand all these things in these coming sessions. So these are the common guidelines of the today's session, or for all of the sessions that you already know. You should follow it. These are the topics that we are going to cover today. So we will understand how to represent any data, what are the various number systems and their representation, how can we represent all these numbers. So we have four types of numbers: decimal, binary, octal and hexadecimal. So we will understand all these number system individually, and in next session we will understand the conversion, how can we convert these numbers, right? Means decimal to binary, binary to octal, right? So we will understand all these conversion in next session. So let's begin with the topic, that is the introduction of data, that is in terms of analog and digital. So first we should know what is data. So data is nothing but the required information, right? And this data is stored, processed and transmitted. Before transmission of any data, what do we do? First, it should be stored somewhere, right? And if it is stored, then before transmission, we have to process that. Like suppose I'm calling to anyone who is 100 kilometers away from here. So what do? We use the system. We use mobile, telephone, whatever. So what is that? We are saying something. It is converted into analog signal, then processed. So processed means we will modulate that, because for sending any information to longer distance, we use the modulation process. So we modulate the signal first and transmit. Okay. Again, it will be received and do the opposite process, whatever is done at transmitter side. Okay. So if it is modulation, then we will do the demodulation process. Why? Because we want to recover the actual information. Okay. So we will again process that. So in journal we say it is processing. Okay. So whenever we have data, so data can be in two forms, analog and digital. So we have to understand what is analog and digital. So we have studied, whatever studied till now was analog. Now we are going to discuss the data in digital form. So in digital form, we represent the data in form of 0 and 1. Okay. So if we have any signal in digital form, it will be 1 1 0 0 1 0 0 1 0 1 0 1. So it will be the combination of zeros and ones only. Okay. So this is basically the digital data. And if we talk about the analog, so you can see in this diagram, it will be better to understand. So this signal is the analog representation. Analog means the signal which is which is dependent upon the time, but this is the amplitude. Amplitude means the height. Okay. So if it is the reference line, right? So this is the height of the signal at this time. This is the height of signal at this time. This is the height of the signal at this time. So we can see that at any time the amplitude may be changed, it may be varied, it may be high, it may be low. Okay, so you can see here it is this, it is this, it is this, it is again this. So at every time, this is at respective time. So at any time we can or cannot have the same amplitude. Okay, so this is amplitude, this is the height of the signal. So this height is not same at every time. It may be same, but it is not required. Okay, it may be changed, it may be increased or decreased. So the signal which is in form of waves, this is wave. Okay, it may be this, it may be this. There is no certain shape of the signal, analog signal. Okay, it may be any shape, right? It depends upon the data, it depends upon the information. Okay, and same we have the digital representation. So digital representation means it may be low or high. There's no third level. There are various levels. This is one level, this is two level, this is three level, this is four level. So it has infinite levels. In analog representation, it has infinite levels, but in case of digital, it has only two levels, high and low. If low is 0, this is low, then high will be this. So whenever we have high, it will be at this height only. If it is low, it will be at reference line, that is 0. Okay. So low is representing 0 and high is representing 1. Okay. So you can see here it is 5 volts. So 5 volt will be represented by this height only. It will be shown at this level only. And whenever it has 5, it will be same height, of same height. Okay, so it is 1 and this is 0, this is 1, this is 0. So it is alternate 1 0 1 0 1, but it is not required. It may be 1 1 0 0 0 0 1 0 1 0 1. Okay, but it should have only zeros and ones, not the third number. Okay, so this is the digital representation, and this analog representation is also a continuous means lagatar, right? There is no break. If it is started from here, then it is ending at this only. So this is one signal. If it is breaking, then there will be two signals. In case of digital representation, this is discontinuous. This is discontinuous. Why? Because at this it is discontinuing the previous and representing 0. So it is 1, it is 0. Okay? It is not continuous. It is discontinuous. Any doubt in representation of analog and digital? Yes, Meena, it is binary. Any doubt to any one of you? Okay, thank you. So before starting the number system, we should know, because these terms will come in between. So we should know what is this. Okay. So basically, these two terms will be frequently used. Okay. But you should know what is nibble and word also. Okay. So what is bit? Okay. So bit, bytes, nibble, word. These are the units actually. Okay, that we are using for the data, for the digital numbers, right? So what is bit? So it is nothing but the binary digit. So it is made up from these two words, binary and digit. So binary and digit becomes bits, right? Bit, from where we got bit? It is the combination of binary and digit. So binary digit is showing bits. Okay. So individual 0 and 1, these are known as bit. So if we are saying 8 bit, so 8 bit means there may be 8 digits, either 0 or 1, or a combination of 1 0. Okay. So if I am saying 4 bit, so 1 0 1 1. Okay. 1 1 0 1. Whatever you want to write, you can. So it is 4 bits. Okay. And if I am increasing, right, 4, so it is 8. So we will just count number of 1 and 0. How many 1 and zeros are there? Not individual, means count of 0 and 1. So if we are counting, then it is 1, 2, 3, and 4. So 4 bits. 5, 6, 7, 8. So it is 8 bits. Clear? So individually 0 and 1 are known as bits because it is binary digit. So binary digit are either 0 or 1. Clear? And this is the basic unit of data. So whenever we write any this, so we will say that it is 8-bit data. We will say 4-bit data. And what is byte? So byte is the combination of 8 bits. So 8 bits is equal to 1 byte, right? If so, we can say this as 8 bits or 1 byte, right? Either you use 8 bits or 1 byte. Clear? So byte is also the unit. We can use bit or byte. If it is less than 8, then we cannot use byte. We will use only bits. And combination of 4 bits is known as nibble. So it is half of the byte. So half byte is equal to 1 nibble. So we generally don't use nibble. We use bits or bytes only. Okay. And what is word? So it may be combination of either two or more bits. Okay. So a word, yeah, one word is greater than or equal to 2 bits. Clear? So we can say it is word. And what is the length of the word? So if it is, suppose this is written here, example. So if it is 16 bit, 32 bits, 64 bits, so this is the word length. Okay. This is known as word length. Length the means the lambai. Okay, so length is the uh, number of bits. How many bits are there? So if it is 16, so the word length is 16. So we have word having word length 16 bit, 32 bit, 64, whatever we have. So you should remember these two at least, bits and bytes. Bit is 0 and 1, byte is 8 bits, right? Any doubt to anyone? Understood the units? Okay, Manoj. Thank you. So these are the number system and their representation. So we will just directly go to this. Okay. So all these terms will come in between. Okay. Or if you want, then we can understand. So these again the values. What is the place value? What is the total value? What is the base value? So whenever we have any number system that is digital, binary, any number, right? So there will be main value that is known as radix. So we can understand whether the given number is decimal, binary, or octal, hexadecimal. Okay, so it is just showing by radix. So if it is 2, then it is binary. So if anything is written in the bracket and having radix 2, this radix is known as base value. So if it is 2, then after we can say it is binary. Why not decimal? Why not octal? I'll tell you later. Okay, in that topic only. What is the absolute value? So absolute value is the magnitude of the digit in the number. So suppose 7458. Okay. So what is 5? So absolute of 5 of according to its value in number line. Okay. How means what is the value according to the given number? That is the absolute value. What is the place value? Place value means we have already studied in numbers ones, tens, hundred, thousand, like that. Okay, so this is the place value, and total value is the sum of the place values. So whatever we have place values, we will just add all the numbers. So this is basic things that we should know. Otherwise, there is no so much need of all these things. Basic means radix is required. Okay, you should remember radix. That is the base value because it is important. Without which we cannot say whether the given number is decimal, binary, hexadecimal, right? So this is it. So this is written here. So it's important. Okay. So what is decimal? So you have already understood deci, right? Deci means that is the 10, right? And we have studied the number system, so we start from 0. So the number means count of number is 10, and if we start from 0, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will go up to 9. So 0 to 9 numbers are known as decimal. Okay, any number written using these numbers, that is from 0 to 9, will be known as decimal number. But whether it is decimal or not, it is represented by this radix. So if I am writing, for example, 24, okay, so it is 24 or 24, it depends upon this radix. So after seeing this radix or base value, that is 10, we will say that this 24 is decimal number. Why I am saying 24, it is 24 or 24, it will be in next topic. Got it? Right? So you have already studied in 6th, 7th expansion of the number. So is this 123 is written as 3 into 1 plus, right? That is 10's power 0. 2 into 10's power 1 plus 1 into 10's power 2. Okay, so it is 100, it is 20, it is 3. Clear? So you have already studied this thing. So this is decimal number. So this thing will be used in the conversion process. So you remember this process. It will be utilized or we will use in conversion. Whenever we convert decimal to binary, binary to decimal, so this will be used in any one of the processes. So in which I'll tell you in next session, because next session is the conversion process. Okay, so this is the same thing, that is 1457. Obviously it will be 7, it will be 50. You can write directly because you are graduate. It is 400, it will be 1000. What is happening? Okay, so this is here. So if you add again, you will get the same number again, 1457. Clear? Got it? So it's very easy for you. This is the same thing. You can do it. Now we come to the binary number system. Bi means 2. Okay. So again, we start from 0. and the count in decimal it was 10. So we started from 0, 1, 2, 3, 4, go up to 9. But for binary it is 2. So you start from 0, 0, because we have to count only two numbers. So 0 and 1. After 1 it is completed. Got it? So only 0 and 1 is the range. So 0 to 1 is the range for binary. So 0, 1 are the numbers that can be used for binary number system. Got it? That's why there are only 0 and 1 for any binary number. Clear? So here it is an example, and whenever we write any number 101, for example, so it should have 2 here, because it 101 can also be decimal number 101. I am telling 101. Why 101? Because it is not decimal. But if I remove 2, if I remove, sorry, remove 2, now whether it is 101 or 101. So we can call it as 101 or 101 after showing this radix number only. But here we have removed the radix. So it should have radix value. Okay. So it should have either 2 or 10 at least. So because we are talking about binary number system, so it should be 2. Okay. And after writing 2, we cannot say 101. It is 101. So individual we will call the numbers. Clear? So this is an example that is 1011. So this is binary number, and if you want to know what is its decimal value, so what is the question? That is to convert the binary into decimal. Okay, clear? So what we are doing here? So we are doing the division process. So whenever we convert any number into decimal, we will do multiplication process. We will do multiply. What multiply? That we just done in this process. This one. So same process will be used. Here it is 10 because it was binary. That will be 2 because that is binary. It is decimal, that is why we are using 10. But the topic is binary, so in place of 10, we will write 2. Okay. So same thing, we will put this 1 into 10's power 0 plus second one into 2's power 1 plus 0 into 2's power 2 plus 1 into 2's power 3. So it will be 8, it will be 0, it will be 2, it will be 1. So it will be 11. Now this is not 1 1, it is decimal, so we will write 10 here. So it is 11. So this number 1011 is showing binary value of 11, right? Why I am calling 11? Because it is decimal value. If it is binary, we will call 1 1, not 11. Getting? Understood, everyone? How can we convert it? Okay, right. And this is the division process. So division will be done in opposite process, that is decimal to binary. So what is decimal number? For example, it is 14. So what we are doing? We are dividing by 2. So it is directly divisible by means 7 times. So 2 7 is 14. Nothing is left. Remainder is 0. Again we'll divide by 2. 2 3 are 6. 1 remainder, it will be written there. Again we will divide it. 2 1 are 2. 1 is remainder, we will write here. Okay. And we should further divide it like this. So it will be divisible by 0 times. Okay, right? This 1 1 0 is already written there. So this one is completely left, means will be pending or leave. So we will write here, clear. And finally we will write bottom to top. So it is 1110, and this is binary number, so it will be 2. These three numbers are these three numbers. I have written as it is. I have copied from there. Understood both of the processes? Binary to decimal and decimal to binary? Any doubt you can ask me. Okay. Okay. These are the two examples. Please give me the decimal value. All of you solve it and give me the answers of both this and this. Do it fast. Give me the answer of these two questions, 1100 and 1101, right? All of you do it and give me the answer. It is 1 2 or 12. How can I call it? Should I call 1 2 or 12? So how can you make me understand that whether it is 1 2 or 12? Yes. Okay. Thank you. Right, right. Thank you. Because it cannot be typed, na? Second answer is 13. Okay. So the answer of this is 12, that is this, and it is 13, it is this. So I'm giving you one number, that is 8421, directly to write the binary number. Okay. Similarly, you can add 16, you can increase it. Okay. 1, 2, 4, 8, 16, 32, 64, right? Like that. So if you want to write any binary number directly, you can use it. So basically we use for these numbers. So what is that? You write the same number here below this. This one below 8, this one below 4, this 0 below 2, and this 0 below 1. Okay. So below which it is, so we will just see ones, all ones. So we have two ones below 8 and 4. So what is this? 8 plus 4, that is 12. So this is this. Got it? Second question was 1101. So this was 12 and this one will also be added. So 8 plus 4 plus 1, that is 30. Okay, so you can write all numbers from 0 0, 0, 0, 2, 1, 1, 1, 1. So all 0 means there is no 1, that will be showing 0 decimal value. These all are ones, it means 8 plus 4 plus 2 plus 1. So it will be 15. So 0 to 15 can be represented by 8, 4, 2. Got it? So if I ask you to write the binary value of 8, so what will be there? Just write 1, remaining will be 0. If direct these numbers are asked, 8, 4, 2 or 1, then it is directly written. But if I ask you the number like 9, so it will be first bit will be 1, last will be 1. 1001 will be the 9 number. Okay. So this is the right process and the fastest one. Understood everyone? Now we come to the octal number. Octal means 8. And 8 means we will start again from 0. So it will go up to 9. Okay. So the range of octal number will be 0 to 7 only. Clear? So highest range was up to this topic that we covered is decimal. It was 0 to 9. Binary was 0 to 1 only. And octal is 0 to 7. So what we can say that these numbers are falling inside or in between decimal number. So we have to carefully write that whether it is octal or decimal or binary. Clear? So radix is very much required there. So if I write 1, 2 again, so if I write 10, then it is decimal. If I write 7, oh sorry, 8, then it is octal. So it can be possible if we write radix value. If we are not writing radix value, then there will be doubt whether it is decimal or octal. Clear? So same number can be represented means for octal as well as decimal. But it cannot be binary because binary can have only 1 and 0. Okay. So I can write that also 1, 0, 1. So if it is 10, then it is decimal. If it is 8, then it is octal. And if it is 2, then it will be binary. Okay, because every number is started from 0. 1 is also coming in this as well as this. Clear? So number having 0, 1 will not binary, always binary, right? It may be decimal or octal also. Clear? Any doubt? So this is number, that is this 8 is showing that it is octal. So it is not 215, it is 215. Okay, and we want to convert it into decimal. So what we did in the last two topics, decimal and binary, we multiplied the number by the number having power. So here, there was 10, we multiplied by 10. There was 2, we multiplied by 2. Now it is 8. So we have multiplied by 8 power n. So we will start from 0, then 1, then 2, then 3, so on. Okay. So there are only 3 digits, 2, 1 and 5. So we multiplied this 2, 1 and 5 by 8 having increased power. Okay. So 0, then 1. So it will be increased from right to left. So 0, increase by 1, 1, increase by 1, 2, and so on. We have only 3 numbers, so it will go up to its power 2 only. So we will just solve it and we will get 141. So we will write like this 141. It is not 141, it is 141. Sorry, it is decimal. We can say 141 and it is 10. Right? So whenever we convert any number into decimal, we will multiply it by that number only. If it is binary, we will multiply by 2 raised to power n. If it is octal, then we will multiply by 8 raised to power n. Okay. Now give me the answer of these two. Do it fast. 205. Manoj is asking, any number which having power 0, it's considered as 1. Yes, 8 raised to power 0 is 1. Okay. Who is asking? Okay, Yogita was asking, sir, how to 5 into 1 if 5 into 8 is power 0? Okay, 8 is power 0 is 1, 1 into 5 is 5. Okay, Yogita, got it? Meenal, you have already written 10 after brackets, okay. Yogita, have you understood how it is 5 into 1? Any number having power 0 will be 1. The value of that number will be 1. Okay. So first answer is 205 and second answer is 173. Is it same for all? Are you getting any difference? So I'll just do it fast. So it will be, I will write from here because 5 into 8 is power 0, 1 into 8 is power 1, plus 3 into 8 is power 2. So 64 into 3, 192, plus 8 plus 5. To solve it, 205. Right? It is the answer of this question. Now I can write here directly 5 into 10 to the power 8 power 1, 5 into 8 power 0. Okay, it is 128 plus 40 plus 5. So it will be 13. Okay. So I hope you all have understood how to solve these questions. So any number to be converted into decimal, we have to multiply by the radix value having increased power. Yeah. So it is 8. So we multiplied by 8. Right. So it's very easy. and last number is hexadecimal. So decimal means 10, hexa means 6. So it is 16. So radix value will be 16. And again we will count from 0. So if we start from 0, so it will go up to 15, less than one value, that is 15. But the number can be represented by single value. Okay. So out of this 0 to 15, we can write 0 to 9 directly, it's okay. But what about 10, 11, 12, 13, 14, and 15? These are two digits number, right? So what we can do? So in hexadecimal, we will use alphabets. Okay. So for 10, we will start from A, it is B, it is C, it is D, it is E, it is so A, B, C, D, E, F. F till F we will use for hexadecimal number for 10 to 15 only. So for 10 to 15 we will use A to F, right? Sequentially A, B, C, D, E, F, right? So these six numbers will be represented by alphabets and remaining 0 to 9 by 0 to 9 only. So you can see in this table up to this it is same, but after that 10, 11, 12, 13, 14, 15 it is A, B, C, D, E, F. So this whole range 0 to 15 is split into two parts, 0 to 9 and 10 to 15. Got it? So you can see, so if I give you any number having alphabet, so you need not to see whether it is octal, decimal or any number, it is hexadecimal because alphabets are only in hexadecimal. Okay. So 2A. So A is only in hexadecimal. So you need not to, but as per rule, we should write 16. As per rule, we should write 16 whether A is there or not. Doesn't matter. If it is 23, it is 16. Then what will you do? So we should be habitual to write the radix value, right? So what we can do for conversion to C? So we will again start from C into, now it is 16 s power 0 into 2 into 16 s power 1. So it is 2 into 16, it's okay, but we cannot multiply 16 s power 0 by C because what is C? So we need to write in decimal. So what is its decimal, respective decimal value? So we will write here 12 into 16 is power 0 is 1. Okay. So it is 32, it is 12 into 1 is 12. So it is 40, right? So I hope you all have understood this conversion, hexadecimal to decimal number. So I am giving you two questions. Right? So question will be asked like this, bracket question mark, because question mark means we have to find that value, and this radix will tell you in which form do we want. In this session we are just converting any number into decimal only, but in next session we will inter convert, or inter means binary to octal, octal to hexadecimal, hexadecimal to decimal. Okay, so hexadecimal to decimal we have already done, but in another form we can do it, so it will be done in next session. So whenever you are asked to convert, then see this radix first, because this radix is required. In which form do we want, right? Do it and give me the answers. Manoj, 4478. हाँ, ठीक है. Everyone should do, right? Since it is capital E, right? Capital, uppercase. It is not lowercase. All the alphabets should be in uppercase only. Okay. It will be wrong actually. The representation is fixed. It is uppercase of A, B, C, D, E, F. Everyone should do. What about the others? Krish, Riya, Vansh, Amania, Amina Khan, Rahul, Shani Kumar, Ritik, Sanjana, Prasanjit, Khushbu. So many students are there. Everyone should do. If you don't do, then how will you do in the examination? Practice makes the man perfect. You should do the practice. Whenever you are asked to do, you should do. Okay? Grab the chance. Because in most of the classes, we are just listening. But if I am giving you the chance to do something, you should. Okay? Okay. 299. Samarth, have you done? Samarth. Who is HP? Please change your name. I already told you to everyone that whenever you join the session, you rename yourself in the beginning. I don't want HP and these nicknames. Okay? Your actual name should be there. The next session, you should change your name. Join by your real name. Okay? 64, 15, 256, 11. What I gave? Okay. So, okay. Okay, well done. So I hope you all have understood all the three numbers. What we discussed today, we discussed about the representation of analog and digital numbers, okay, or we can say digital signal. So in analog form, the signal is in continuous form, while in case of digital, It is not continuous because it is 1 or 0. It may be continuous 1 1, but after changing from 0 to 1 or 1 to 0, it will be shifted. The level will be shifted from higher to low or low to higher. Okay, so it is not continuous. And in number system, we have studied about decimal, that is ZX10, binary, that is ZX2, octal, that is ZX8, and hexadecimal, ZX16. So all these numbers are having, in decimal the range is 0 to 9, in binary it is 0 to 1, in octal it is 0 to 7, and in hexadecimal it is 0 to 50. In all the cases it is same, but in case of hexadecimal the range is splitted. Why? Because the range is from 0 to 15. So if we go beyond 9, we have two digits number, that is 10, 11, 12. So all these two digit numbers will be represented by A to F. That means 10 to 15 will be represented by A to F alphabets. Okay. So whenever we convert, okay, like this, we need to write those alphabets in its respective decimal value. Then after we can solve it, because we cannot multiply a by 4. Can you do? No. So you need to write a first. 10 into 4, that is 40. Okay. So this is the conversion process. So in today's session, we understood all these four types of number system and their conversion from that number to decimal only. In coming session, in next session, we will discuss about the conversion from one number to another, like octal to binary, binary to hexadecimal, like that. So this is the summary that we have understood all these things. What is data? What is a representation? What is analog? What is binary? We have discussed about all the number system, various number systems. These were the keywords that we used, bits and bytes. And these are some number questions that we have already discussed in between. Okay. So what we covered the representation of data. We understood the concept of digital and analog data. What is digital system? We understood. What are the various digital number system? Okay. So we have studied and covered all these things. So in next session, we will start the conversion process. If you have any doubt, you can ask me any doubt. No doubt? Uh, Chapter 4 video. Uh, I'll ask to the team, right? Because whatever the lectures are delivered are uploaded, I think. Thank you, Manoj. Thank you. But I'm asking because you didn't take that lecture. What lecture? Whatever I delivered, the lecture is uploaded, or if it is not uploaded, I'll ask to the team. Okay, Minal? Okay. Okay, Manoj. Meanwhile, don't worry if anything is not suppose delivered or anything. You can ask me in the next. I'll take one more lecture. No, don't worry. Okay, there is no problem. Okay, Minal. I'll take one or two more sessions. I don't have any problem. But it's your duty to remind me, sir. You have to deliver this topic again. I'll right. Okay. Okay. Thank you so much. Happy learning. Thank you. Take care. Bye bye. We will meet in the next session. Thank you.